For this next part, we'll be talking about type 1 and type 2 thinking. This falls under the dual process model of thinking. So many theorists propose that we generally have two forms of thinking, one that is fast and effortless, and this is oftentimes called a type 1 thinking, while the other tends to be slow and effortful, which is often referred to as type 2 thinking. So type 1 thinking is often based on heuristics. We already talked about the availability and representative heuristics. And a lot of times, because of how fast we are making these type of judgments, this is driven by or falls under type 1 thinking. Whereas type 2 thinking is often more rationally driven, where someone takes time and thinks through sort of the logic of whatever they are approaching. Now, please make a note here that just because this is associated with a more rational or logical way of thinking doesn't necessarily mean that it's always going to be right or that it's superior. There are pros and cons of using either type of thinking in different situations. And rationality is only ultimately as good as the inputs or givens that are given to a situation. You might be perfectly logical and be able to follow logical steps 100% accurately, but if your input givens are incorrect, your ultimate conclusions are also going to be incorrect regardless of how good your logic or rational approach was. Part of being an effective decision maker is not only being able to think things through logically, but also being able to evaluate the quality of the information that you were given. Now, while many people would probably like to hope that they can pick and choose when they use what type of thinking, the evidence suggests that that's not so much the case, and rather the type of thinking that we engage in is largely driven by the external cues that are available to us and the situations that we find ourselves in. Also, somewhat our personal experiences will also impact the type of thinking that we engage in. So some examples of this are when under time pressure, we are much more likely to engage in type 1 thinking over type 2 thinking. Just remember that type 2 thinking requires much more effort and takes time to engage in it. Just think about solving a math problem versus pulling something out of the fridge. One you don't have to think about at all, whereas the other one you actually have to spend some time thinking about. So if you are under time pressure, solving math problems is probably going to be very difficult, whereas grabbing a beer on your way out before you're going to the park, much easier. You don't really have to think about it, and that time pressure is not as likely to affect you. Another factor that makes type 1 thinking much more common is if people are tired or anxious or stressed out, they will engage again in this more effortless type of thinking because of exactly that they don't want to or don't have the resources to put into that more effortful form of thinking. This is why after spending a whole day at work and then cooking food for your dependents and then trying to study is going to be very difficult because your studying often requires a lot of type 2 or effortful thinking, and if you have exhausted yourself over the course of the day because of your other various requirements, it is just going to be that much more difficult than if you approached it with sort of a fresh mind and no time pressure also. Now, a lot of people have this preconceived notion or stereotype, let's say, that type 1 thinking is bad and type 2 thinking is good. And it is definitely not that simple. There are advantages to both of these. For example, type 2 thinking can be appropriate when we're dealing with certain societal factors where we actually have to step back from our own experience and be able to not only empathize, but think about the world or societal context from multiple different perspectives and other people's experience points of view, along with the complexities of trying not only to solve the problems that we see, but also the original systemic issues that led to many of those problems. Right? A lot of that can't just be based on a snap judgment. And in those cases, that effortful and rational type 2 thinking is probably advantageous. If you happen to be in the savannah and there was a lion that was about to eat you or pounce on you, let's say, at that point in time, type 2 thinking is not going to be very helpful. Type 1 thinking is much more efficient there. You don't want to stop while that lion is approaching you and be like, oh, well, it is brown, so it could be a deer, but it could be a lion, or it could be a dog, but it is quite large, so okay, maybe it's this type of creature. By the time you've worked through all of these options, chances are those human beings are no longer alive and contributing to the gene pool. Again, it just shows that the situation that one is in is Well, let's say it this way, that the type of thinking is determined by the situation you're in, but also what type of thinking is adaptive is also determined by the situation, where there are different advantages to both types of thinking, which is probably one of the reasons why we are capable of both of these. Now, another fascinating thing that comes up is that oftentimes people think of type 1 thinking as just being sort of quick and dirty and simple, just because of how fast it is, whereas type 2 thinking is sort of much more complex and elaborate. But that too is not necessarily the case, and there are quite many situations where type 1 thinking can be incredibly sophisticated. So a couple examples of this are firefighters. They are known, especially after some time of being firefighters, to be able to accurately predict whether burning buildings are safe to enter or not. And if you ask them about how they know, they won't be able to tell you. They'll just say that, like, I have a feeling or I just know. And what's actually so surprising about this is that their predictions about whether buildings are liable to just collapse very quickly or not are actually highly accurate. They're far above chance in their ability to make these kinds of distinctions. And they're able to make that judgment very, very quickly. I mean, we're talking about like near immediate. A similar finding is found for nurses and some type of doctors in their ability to diagnose various illnesses. And a lot of times what will happen is they will be able to enter a room and just look at a patient and be like, oop, I think it's this, before any type of medical tests or things have come about. Now, of course, they don't just start treatment based on their feelings about it. Later on, they do tests and things, and they come back and oftentimes support these conclusions. But here, again, what is quite surprising is many of these nurses will say that they don't exactly know how they know, they just had this feeling or they knew, and they will be right more often than not. And so this just again shows that type 1 thinking can be incredibly sophisticated and lead to accurate and adaptive judgments. Now, what is thought to contribute to these experts being able to make sophisticated type 1 judgments is related to three different causes, or three different things are thought to contribute to this. The first is that the environments that these people work in, they have a lot of cues that can guide their behavior. So for those firefighters, it could be things like the size of the fire, maybe the color of the flames, the type of building, how tall the building was, how many windows there are, is it a really dry day, is it raining, and all of these different little situational factors that are present around a burning building will all give clues on how safe or dangerous it is to enter that building. And of course, having multiple cues by which to guide your behavior is oftentimes going to lead to more efficient decision making in many cases than having only one cue to go off of. But even that is dependent on the type of judgment. The second big thing that leads to these sophisticated types of thinking is the opportunity that many of these people have to see many, many cases. So for firefighters, for example, they don't just respond to one fire a year. Most firefighters are constantly going from one fire to another, and so they get to see all different types of fires and buildings and things burning and so on and so forth. So they get a lot of exposure. The third is these people get pretty quick feedback about whether their estimation was correct or not. So with these firefighters thinking about whether a building is susceptible of collapsing and being dangerous or not, chances are within that day that they're fighting the fire, they're going to know if that building collapses or not. And so they will get very quick feedback about whether or not their estimation was correct. Same type of thing for the nurses, where they can make an estimation of, I think this is the pathology, and then very quickly they'll get tests back from the various laboratories that will either confirm or deny that estimation. Another way to think about how this is working sort of on a cognitive or brain level is that this is very similar to muscle memory. So first of all, muscle memory is not stored in the muscles. Many people think that it's in your muscles, but your muscles don't actually remember anything. All your muscles really can do is contract and relax. Now, what actually is going on here is when you are able to have something quote unquote in muscle memory, it has been encoded into the cerebellum of your brain, where the entire sequence of action patterns and behaviors have been recorded and encoded in this sort of sequential response. And so it can just be engaged, and then it just sort of is an automatic process that carries on and the behavior takes part. Now, if you think about how one builds muscle memory, One repeatedly engages in a certain type of activity and performs lots of little corrections, and then can see also the effects of whatever those actions are, which also allow them to modulate those actions, and then they repeat this over and over and over. In the same way, these people ultimately build up a quote-unquote muscle memory for these types of phenomena. The firefighters continually see and practice and engage in dealing with fires and buildings that are burning, and are able to build up sort of this overtime repository of knowledge, even though they might not always directly be able to consciously access that knowledge. Just like when we walk around, we don't actually have to think about how it is that we're walking around. We just walk, and that's how it works. We just go. So in that same way, this is how with training one can build up highly sophisticated type 1 thinking that can allow people to make decisions very, very quickly, which in some cases is highly advantageous. Right? You want your firefighters to be able to very quickly decide whether a building is safe or not, so that they can go in and save people, or make this sort of, well, what is probably unbelievably a difficult situation of how many firefighters' lives to put on the line to save certain civilians. Now, sophisticated type 1 thinking is luckily not just limited to experts, even though that's where we tend to find the most sophisticated versions of this type of thinking. But if the environment and situational cues are such, they can ultimately lead to a greater sophistication and higher rates of accuracy in type 1 thinking. So a relatively straightforward example of this is when people are having to do with base rates, like what we talked about earlier, of how often does something occur in a population. If this information is presented to people in terms of frequency, so something like 1 out of every 20, people are much, much more likely to use that in their judgments, even if they're making relatively fast type 1 style judgments, than if that information is presented as percentages or proportions. So 1 out of 20 is actually the same thing as 5% or a proportion of 0.05. All of those are, functionally speaking, exactly the same information, but people are much more likely to disregard percentages and proportions as opposed to frequencies. Now, this is thought, at least, to just be that frequencies are much more intuitive, and we learn to count sort of out ofs at a much higher rate, or we do it for longer during our educational process, whereas many people tend not to use percentages very much, and even less proportions. You can see this again in just how certain people approach math and what parts of math are easier for them than others. And so here again, a lot of this is ultimately related to training, but it does seem like there are certain contextual things that lead us to pay attention or disregard things based on how easy it is for us to relate to them. Related to that, the way that information is coded strongly impacts how we will use that information in our judgments. So maybe you have, but hopefully, or I wonder if you've ever wondered why some people can just remember and use all manner of statistics when dealing with the sport they love, like people who like baseball, and they can just go on and on about the statistics about games and baseball, people and teams and so on and so forth. But when you stick them in a stats class, they often flounder, or if you put them in situations where they have to use similar statistical reasoning, they do not really bring that to the table. And a lot of this comes down to how that information is coded, both in terms of how it is presented and then how we internalize that information. So in sports, again, let's say using baseball, a lot of that information is not only continually presented in statistical terms, but it is presented in statistical terms that are relevant to the interests of the person. This is a sports lover in this case. And it also is presented in bite-sized or easily digestible ways. And this will ultimately lead them to make accurate judgments in that sort of sports domain, and those judgments will reflect the correct usage of statistical reasoning. Conversely, in a lot of real-life judgment settings where you could benefit from bringing to bear the same type of statistical reasoning, we oftentimes won't, just because the information is not coded in that same way. So for example, if you were trying to think about how many people on welfare are there just due to accidents that they had at the workplace, a lot of times we don't know anything about the statistics relating how many injuries occur at the workplace and what proportion of people on welfare are there because they suffered injuries in the workplace. And this could have a dramatic impact on how we make judgments about whether to support or work against such type of welfare programs. And in those contexts, we're likely to not use a high degree of statistical reasoning, not so much because we don't know how, but rather because the way those problems are presented to us don't make it readily available that those statistical concepts are relevant here. Finally, another factor that really strongly impacts our thinking abilities is our education. And this ultimately applies to both type 1 and type 2 thinking. Now, not just any education. You can't just go to college, get a 4-year degree, and magically you're going to have better thinking. On average, sure, but it's not that simple. So education that focuses on things like statistical reasoning, logic, and decision fallacies, or critical examination, debate is another good one. These are all likely to improve people's thinking abilities. Education that's largely focused on memorizing material or just trying to get grades without actually internalizing the material is unlikely to help quality of thinking very much.